Yeah, I can continue now. The derivatives of the first principle I am going to explain now. Yes, you write, find the derivative of sin x by using first principle or cos x. You can write find the derivative of find the derivative of find the derivative of sin x. First, to learn the formula, find the derivative of sin x from first principle. From first principle. Using first principle, you should find this. From the first principle, find the derivative of sin x from first principle. So when they are asking this by using first principle, you find here, the first you write, let f of x is equal to sin x. F of x is equal to sin x. Now you take the first principle, f dash x equal to limit h tends to 0. F of x plus h minus f of x by h. You write first principle formula, right? Limit h tends to 0. You think what is f of x plus h? H tends to 0. F of x plus h means f of x sin x. F of x plus h. Replace x with x plus h. Sin of x plus h minus f of x is sin x by h. Right? I can write like this. Limit h tends to 0. Now, you know sin of a plus b formula. What is sin of a plus b? Sin a cos b plus cos a sin b. Remember sin of a plus b. You can expand this. Sin x cos h plus cos x sin h minus sin x by, I can write h. I can write like this. See that I can write like this. The thing I can express this one. So I expand sin x cos h plus cos x sin h, or I can apply sin c plus sin d formula also. I have written cos x sin h minus sin x by h. Right? This one. Because I can do two ways also this problem here. If I apply the h tends to 0, you are getting h tends to 0 here. This only how to simplify this. That is important here, how to simplify this. If I limit the limit, this is I can separate this limit, because sin x cos h by h and cos x sin h. If I do like this, the thing is h tends to 0 means cos 0, but h tends to 0 can the denominator is this one here. If I split this, I should simplify. I won't cancel here sin x into cos h minus 1. This is cos x into sin h by h. If I write the words like this, cos h minus 1. Otherwise, I can tell you another way also, this problem. Instead of doing that, we can simplify sin c minus sin d also. I can use it. Limit h tends to 0. Apply sin c minus sin d. This is by h. You apply sin c minus sin d. What is sin c minus sin d? You got 2 cos c plus d by 2 sin c minus d by 2. Remember this formula. Sin c minus sin d, right? This is sin c minus sin d. 2 cos c plus d but sin c minus d, but that will be useful for you here. Limit h tends to 0. If I apply this, I can write 2 cos c plus d, x plus h plus x, x plus h plus x by 2 into sin x plus h minus x by 2 by h. Correct. Now here plus x minus will get cancelled here. I can write this one you can limit h tends to 0, 2 cos, this is 2x plus h by 2 into limit h tends to 0, I can write sine 1 by 2h by h. You apply the limit here, 2 cos of 2x plus 0 by 2. This one we know that limit theta, you know that limit theta tends to 0. You remember limit theta tends to 0. Sin n theta by theta is equal to sin n theta by theta is equal to n, where theta should be in radians. You know the way theta should be in radians by n, like this will be off. So 2 will get cancelled. Cos 2x by 2, it will be cos x. So the derivative of sin x is cos x. When I have taken f of x equal to sin x, the derivative of sin x is cos x. So this is the easy method you can think. You have written f of x equal to sin x, f dash x equal to limit h tends to f of x plus h minus f of x by h. Replace x with x plus h, sin of x plus h minus sin x by h. Sin c minus sin d, 2 cos c plus d by 2, sin c minus d by 2 by h. Then you rearrange this. Then limit theta tends to 0, sin n theta by theta equal to 1, where theta should be in radians. Follow this formula, you will get sin 1 by 2 h by h. Then this will be off, 2 get cancelled, cos 2x by 2, because this is plus 2x plus 0, 2x by 2 cos x. So remember, the derivative of sin x is equal to cos x. So d by dx of sin x will be cos x. It will be cos x. Is clear? Understood this? It's clear? I hope you got this point right. Should I repeat again? Right. I hope you understood it. Can I clear? The next one. Find the derivative of cos x. Same thing. Find the derivative of cos x. Suppose they are given f of x is equal to cos x from first principle. From first principle only. They are asking to find from first principle. Using first principle you should find. From first principle. Right, same thing, you can write f dash x is equal to limit h tends to 0, f of x plus h minus f of x by h. Same formula I can write. Now if I written the same for this one, I can write limit h tends to 0. Now same thing, cos of x plus h minus cos x by h. Minus cos x by h. But remember, always you should remember, when you are taking cos c minus cos d, cos c minus cos d, remember this formula, this will be 2, you get minus 2 sin c plus d by 2 into sin c minus d by 2. If I use this formula, minus 2 sin c plus d x plus h plus x by 2 into sin x plus h minus x by 2. Correct. Now you can see here plus x minus x will get cancelled here. By h is here, we have by h. Correct. By h we have, right. Now you see, I can write this one. Minus 2 sin 2x plus h by 2. Because I can write here, this is 2x plus h by 2 right? This one is sine h by 2. 1 by 2 into h by h I can write. If I apply the limit, product of the two functions here, if I apply the limit minus 2 sine, apply the limit 2x plus 0 by 2, limit, because here I should continue this limit also. Sorry, I should continue limit h turns to 0. Limit h turns to 0, I should continue. Apply the limit. Limit h turns to sine 1 by 2 h by h, this will be 1 by 2. So 2 will get cancelled. You will get minus sine 2x by 2, this is x. 2x by 2 will be x minus sine x. That means derivative of cos x is minus sine x. d by dx of cos x is minus sine x. Check that. Is it clear? Should I explain again? Derivative of cos x is equal to minus sine x. Right. Derivative of cos is equal to minus sine x. Remember, this is the, like you will write, you remember as a formula. When they are asking by using first principle, you should do like this only. So just you see here, I would take given cos x from first principle, they are asking. Write the formula, then replace cos of x plus h minus cos x by h. Limit h turns to minus 2 sine c plus d by cos c minus cos d, minus 2 sine c plus d by 2 sine c minus d by 2. Follow the same thing, c plus d by 2, c minus d by 2. Then you simplify like this. Then apply the limit 2x plus 0 by 2. This will be, if you apply the limit for this, this will be 1 by 2. If you want to get a limit of this into limit of this, you can write. We get minus sine x. So derivative of cos x is minus sine x. Now we will explain one more. Find the derivative of tan x from first principle. Find the derivative of tan x. F of x is equal to tan x from first principle. They are asking from first principle, find the derivative of f of x equal to tan x from first principle. They are asking from first principle only. What is the derivative of this? First principle they are asking f of tan x from first principle. They are asking from first principle. So when they are asking first principle, same again, write the formula f dash x is equal to limit h turns to 0 f of x plus h minus f of x by h. Write the formula again, limit h turns to 0 limit h f of x plus tan of x plus h minus tan x by h. You write the formula, just you write that. But we know that tan x is sin x by cos x. We know that tan theta, sin theta by cos theta. Same thing, we know this is tan theta, sin theta by cos theta. Similarly, I can write limit h tends to 0, 1 by h into tan means sin of x plus h by cos of x plus h minus, I can write sin x by cos x. I can express like this. Correct. Now, you take LCM here, limit h tends to 0, 1 by, you take LCM, cos of x plus h into cos x. So this will become sin of x plus h into cos x minus cos of x plus h into sin x. It will come like this, right? Limit h tends to 0, 1 by h. You apply sin a cos b minus cos a sin b. Think this is sin a cos b minus cos a sin, related to this is a, this is b. Sin a cos minus cos a sin b. If you consider like this will become sin of a minus b, x plus h minus x, x plus h. Because what they are talking about, this is sin of a minus b, sin of a, this is b, minus x. by, I can write this one, cos of x plus h into cos x. Now I can write x will get cancelled. So we can write limit h tends to 0. H tends to 0. I can write sin h, this is sin h by h, into limit h tends to 0, 1 by cos of x plus h into cos x. Again cos of x plus h into cos x, I can write this one. Cos of x plus h, this one same thing. Cos of x plus h into cos x. Cos of x plus h into cos x. If I apply the limit, this will be 1. We know that this is 1. Correct? I can write this is. So what about this one? Applying the limit, we know this is the formula. This is 1. Apply the limit. Cos of x plus 0 into cos x. Because h approaches to 0. You will get 1 by cos square x. 1 by cos, which is equal to secant square x. 1 by cos square x, 1 by cos square secant square x. That means I can conclude that derivative of tan x equal to secant square x. Therefore, d by dx of tan x, therefore d by dx of tan x, d by dx of tan x equal to secant square x. So just I will revise this what I have done now. The basics we are learning this. Derivative of tan x from first principle. F dash x limit h tends to 0. F of x plus h minus f of x by h. This is first principle. Right. Replace x with x plus h. Tan of x plus h minus tan x by h. Take 1 by h into tan theta sin theta by cos theta. Sin of x plus h by cos of x plus h minus sin x by cos x. You take LCM. Then you can think it will be like sin a cos b minus cos a sin b. Then sin of a minus b. X and minus will get cancelled. Sin h by h. Limit h tends to 0 sin h by h. Into limit h tends to 0 1 by cos of x plus h into cos x. This value will be 1. H approaches to 0. Cos x into cos x. That answer will be 1 by cos square x. It will be secant square x. So d by dx of tan x equal to secant square x. We completed this, right? Now, just I will remind you the formula now. What we learned just now, d by dx of, you see, d by dx of sin x. D by dx of sin x is cos x, we learned just now. And d by dx of cos x. Because it's like the formula you can remember. Derivative of d by dx of cos x. So derivative of cos x is minus sin x. Derivative of sin x is cos x, derivative of cos x is minus sin x, and d by dx of tan x. When I have taken tan x, this is cos. Derivative of cos x is minus sin x. Derivative of tan x, secant square x. Next, d by dx of, you remember, these are all we are learning this. Already I proved all these three. Similarly, d by dx of, you write this one. I can write all the secant x tan x. Remember, secant x tan x. D by dx of cosecant x. D by dx of cosecant x. D by dx of cosecant x minus cosecant x cot x. 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 D by dx of, I have written sin cos tan secant cosecant cot x minus cosecant square x. Always remember, when the term starts with c, you see all these three, right side will get negative. Term starts with cos, cosecant, cot, the derivative becomes negative. Derivative of cos x minus sin x, derivative of cosecant x minus cosecant x cot x, derivative of cot x minus cosecant square x. Minus cosecant square x. How I have done the previous these three. Similarly, you can do all the remaining three also. Because we know that the reciprocals here. Sir, suppose you are talking d by dx of secant x, 1 by cos x, right? You can apply the formula. Derivative of secant x tan x. But we know the relation, sin x means 1 by cosecant x. Cosecant x means 1 by sin x. Next, cos x means 1 by secant x. Secant x means 1 by cos x. Tan x means 1 by cot x. Cot x means 1 by tan x. We can use that. This is cot x. Cot x equal to minus cosecant square x. So this is the trigonometry 6 we have. Six trigonometry functions. These are the derivatives of that. So they may ask, find the derivative of any function from the first principle they may ask. But you should be familiar with all these 6 functions. Now, using this I am going to explain the 11th main. I will explain the 11th main now. We will solve the problems in 11th main. Find the derivative of the following functions. Find the derivative of the following functions. Find the derivative of the following functions. So d by dx of sin x into cos x. They are asked what is the derivative of sin x into cos, d by dx of sin x into cos x. Derivative of sin x into cos x they are asking. What is the derivative of sin x into cos x? The product rule. This is the product rule. So what is the product rule? You know that d by dx of uv. What is uv? U into v dash, v into u dash. So I can write here sin x into, just compare with the right side uv formula product rule. Sin x into, I can write sin x into d by dx of cos x plus cos x into d by dx of sin x with respect to dx only. Sin x, I am doing with respect to sin x. Derivative of cos x, I can write now sin x. Derivative of cos x is minus sin x. How sir? Look into this. Derivative of cos x minus sin x plus cos x into derivative of sin x cos x. Correct? Now you can think about this one. It comes like this. I got like this. Sin x into cos x plus cos and sin x. Derivative of sin x is cos x. Now you will get minus sin square x plus cos square x. It comes like this, right? Correct? You can see minus sin square cos square. That means cos square x minus sin square x. Cos square x minus sin square x. If you want to make this one, see cos square x minus sin square. This is nothing but cos 2x. Formula we have. Cos square x minus sin square x. You can stop here. Cos square x minus sin square x. Otherwise you can write cos 2x. We can write cos 2x. So that is the formula here. Derivative of sin x cos x is equal to, use product rule. Then we have done using this. We have done this. Right. The next one. They are asking find the derivative of secant x. Derivative of secant x. They are asking d by dx of secant x. Secant x. If they ask first principle, you should do first principle only. Simply they are asking find the derivative of secant x. So I can write d by dx of secant x means 1 by cos x we can write. 1 by cos x we can write. Correct? Now you can use quotient rule. You know quotient rule. D by dx of u by v. What is the quotient rule? Remember the quotient rule. When you are comparing quotient rule, so if you do the quotient rule, d by dx of u by v. D by dx of u by v. It comes v square. V into derivative of u. U into derivative of v. Correct? Now if you do this, you can observe this is the derivative of this. I can write cos square x. Correct? I can consider this is cos x whole square. Cos x into d by dx of 1. Quotient rule. Because this is v, this is u. Next I can u into, I can write 1 into d by dx of cos x. Cos x. I am using, if we use like this, I can write now cos x into derivative of 1 0 minus derivative of cos x minus sin x. Correct, we know that. Derivative of cos x minus sin x by, you will get cos square x. Cos square x. This will be 0 minus, you will get, this is minus positive sin x. Sin x by, I can write cos x into cos x denominator. But we know that sin x by cos x will be tan x. So I can write this one, 1 by cos x. So this I can write, to understand this one I can write sin x by cos x into 1 by cos x. 1 by cos x. So sin by cos tan x. 1 by cos secant x. Tan x into secant x. So finally I can conclude that the derivative of, so the d by dx of, so secant x always equal to derivative of d by dx of, and so d by dx of secant x is equal to secant x tan x. Is the verb, just we learn now. Like this, d by dx of secant x to secant x tan x. You observe here, this is the derivation of this secant x tan x. So now, again I can repeat that secant x tan x Alright. If I repeat this, one by cos x, use quotient rule, then you simplify. Sin x by cos x consider as tan x. 1 by cos x is secant x, tan x secant, derivative of secant x equal to secant x tan x. Like that you can write this. Next one. The next one. What I am doing next one? D by dx of 5 secant x plus 4 cos x. D by dx of 5 secant x plus 4 cos x. 4 cos x. This they are asking 5 plus 4 cos x. Now to simplify this. When they are asking to simplify this one, I can write 5 into d by dx of, I can write here 5 into d by dx of secant x, I can write d by dx of secant x plus 4 into d by dx of cos x. This will become 5 into derivative of secant x tan x. I can write this plus for derivative of cos x minus sin x. Derivative of cos x is minus sin x. If that means 5 secant x tan x, this will be 5 secant x tan x minus 4 sin x. That's all. You can find like this. This is, I want to simplify here. If you write, you get even if sin x by cos square x not required. You can leave like this. That is your answer, right? Next one. They are asking derivative of, see this one, d by dx of, they are asking cosecant x. What is the derivative of cosecant x? D by dx of cosecant x. But we know the derivative of sin x. When they are asking d by dx of cosecant x, this one I can also write d by dx of cosecant x means 1 by sin x, correct? I can express like this, 1 by sin x. Now use quotient rule, 1 by sin x. I can use quotient rule, right? Again, quotient just now we have discussed. So sin square x, quotient rule. Sin x into d by dx of, I can write d by dx of 1 minus 1 into d by dx of sin x. I am using quotient rule. That is d by dx of. When I am using this, I can write denominator sin square x. The denominator is sin square x. Sin square x. This will be sin x but derivative of constant is 0, minus 1 into derivative of sin x is cos x. Correct. Now you can see that I can express this. This is 0 minus cos x by sin square x. Can you write sin x into sin x? Because this one I can write sin square x, I can write sin x into sin x. How convenient we can take it. Now I can split minus cos x by sin x into 1 by sin x. But we know that minus cos by sin minus cot x, 1 by sin cosecant x. So derivative of cosecant x is minus cosecant x cot x. The conclusion I can write now, d by dx of cosecant x always equal to derivative of cosecant x, d by dx of cosecant x always equal to, understood, the derivative of cosecant x will be minus cosecant x cot x, minus cosecant x cot x. So remember this one. Like this, derivative of cosecant x minus cosecant x cot x. Already we discussed about that. So remember like that. They're asking I have done by using I did quotient rule, because we know the derivative of sin x. Using that concept I have done. Correct. If they ask first principle, we should do the first principle using first principle only. We should not do this method. If they ask find the derivative of cosecant x by using first principle, don't do this method. You should do first principle method only. F dash x equal to limit h tends to 0, f of x plus h minus f of x by h. Strictly you should use that. I have done this now. Next one, d by dx of the next problem, d by dx of 3 cot x, d by dx of 3 cot x plus 5 cosecant x. 5 cosecant x. They are asked for the derivative of this. But once if we know the values, right, we can write. I can write 3 into d by dx of cot x plus 5 into d by dx of cosecant x. d by dx of cosecant x I can write. Now we know that derivative of cot x minus cosecant square x. See, I given the list of the formulae. You remember that. Everyone should maintain the list of formulae. 5 into cosecant x minus cosecant x cot x minus cosecant x cot x. So you'll get, if you want I can take it cosecant x common, or you can leave it now. You'll get, if you take it cosecant x common also, if you take it cosecant x, if you take cosecant x common, this will become minus 3 cosecant x plus 5 cot x. For both negative, I can write minus 5 cot x. Even if you take minus cosecant x common, this will become plus cosecant x cot x. Correct? I can make it this one plus 3 cosecant x plus 5 cot x I can write. Like this it comes. d by dx of 3 cot x plus 5 cosecant x. Just write a formula, derivative of cot x minus cosecant square x, derivative of cosecant x minus cosecant x cot x. Then I have taken minus cosecant x common. Right. Like this you will get this. Next one. I think it's clear. Is it clear? I hope you understood this. Anything to explain again, you can ask me, I can explain again. I can do that. I can repeat that. If you want, I can repeat that. Now, I will do the next one. d by dx of d by dx of 5 sin x minus 6 cos x plus 7. Let us find the derivative of this. 5 sin x minus 6 cos x plus 7. See, in this problem, when they are asking this, I can write 5 into d by dx of sin x minus 6 into d by dx of cos x plus d by dx of 7. 5 into derivative of sin x cos x. It will be cos x minus derivative of cos x minus sin x. How do you know this? In the beginning I have given the list, you should remember that. Derivative of constant is 0. So what is the result it comes now? I written directly the formula. It will come 5 cos x plus 6 sin x. So that will be our answer. 6 sin, I have written this is 6 sin x. So then just d by dx of sin x is cos x, derivative of cos x is minus, this is cos x is minus sin x. So 5 cos x plus 6 sin x. Next one, d by dx of, so next problem you can see now, they are asking here d by dx of 2 tan x minus 7 secant x. 2 tan x minus 7 secant x. Everyone should maintain the list of formulae. You should maintain that. Otherwise, keep it the list of formulae in your hand. 2 into d by dx of tan x minus 7 into d by dx of secant x. Even you can remember, you can practice also the formulae. Derivative of tan x, we know secant square. Just look the list of formulae. But you should practice all the formulae. 7 derivative of secant x tan x. I can stop here. Otherwise, I can take it secant x common. If we take secant x common, it will come 2 secant x minus 7 tan x. Like this, I can stop here. Just I have taken derivative of 2 tan x minus 7 secant x. We got secant x into 2 secant x minus 7 tan x. So with this, I have completed 13.2 exercise. 13.2. Now, I can also find extra problems, remaining extra problems we do now. Even miscellaneous exercise, the problems which is required. Next one, we will do the next one. F of x equal to sin square x. They given f of x equal to sin square x. When they given f of x equal to sin square x, they are asking find f dash of x. They are asking find f dash of x. Right? They are given f of x equal to sin square x. Find f dash of x. They given f of x equal to sin square x. They are asking find f dash of x. They are asking to find f dash of x. When they are asking f dash of x, you can see now. Here, in this problem, they are given like this, f dash of x. Can I write f of x is equal to sin square x? But we don't know formula of sin square x, right? But I can write sin x into sin x. Then I can use product rule. Sin square x means sin x into sin x. Now you can use product rule. Once if we learn chain rule, you have in class 12th we have chain rule. In 5.2 exercise you have the chain rule. If you learn that, you can do that. But even though later we will discuss sin x into sin x. If I am using f dash of x, use product rule. Sin x into d by dx of sin x, UV rule, plus sin x into d by dx of sin x. I can write like this. Correct. Now you observe here, I can write sin x into derivative of sin x, we have cos x, plus sin x into derivative of sin x is cos x. So both terms are same. It will come 2 sin x cos x. 2 sin x cos x. Correct? You remember this is 2 sin x cos x. 2 sin x cos x. So you can stop here. Otherwise we can also write, if you want, f dash of x is equal to sin 2x. Correct? 2 sin x cos x, sin 2x. Derivative of sin square x is 2 sin x cos, or you can write sin 2x. If you not remember this, you can stop here. But always you should remember 2 sin x cos x is nothing but sin 2x. F dash x equal to sin 2x. Correct? That you should not forget. You should remember. Just when they are given sin square x, sir, suppose they are given sin cube x. When they are given sine cube x, if you want, you can make it sine cube x like sine square x into sine x. Again you apply this. Again sine square x, again you can split. That way you can continue. You can do that. So right now we learn this. Later we will discuss how to find derivative of sine cube x, sine power 4, sine x whole power, any power, how to find, I will explain that. Next one. So the next problem. Find the derivative of right. Because when they are asking to find the derivative of minus x from first principle. Find the derivative of minus x from first principle. Find the derivative of f of x equal to minus x from first principle. Find the derivative of f of x equal to minus x from first principle. They are asking find f dash of x, f of x from first principle. They are asking you should find derivative of this from first principle. You should find. Then how to find derivative of this one using first principle? When they are asking using first principle, again, when they are talking first principle, always remember, always you should write f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. You should write limit h tends to 0. Then again write this is the function minus of x plus h. My f of x is minus x by h. Correct? Now this one you can think the simple only this one, but we know already before that. I will tell you that before doing this one I can find f dash of x. What is f dash of x? You can find f dash of x will be minus 1. Derivative of x is 1. Final answer you should get minus 1. Limit h tends to 0. It is this minus x minus h plus x by h. Correct. Now you can see this one minus x plus will get cancelled. Correct. Because here I have taken this one as plus x, right. Now we have this one limit h tends to 0. H tends to 0 minus h by h. H's will get cancelled. Limit h tends to 0 minus 1. Limit of constant is constant. So answer will be minus 1. See, since they are asking using first principle, you should do like this only. But we know directly how to do that. F dash x equal to minus 1, you can verify. The answer you can verify. So f of x equal to minus x from first principle I have done. Write the first principle formula. Then replace x with x plus h minus of x plus h minus of minus x. Simplify. The derivative becomes minus 1. Right. By using first principle. Correct. Now I am doing that after that. So we are trying to find using the first principle formula. You are finding right. Next one. Find the derivative of f of x equal to f of x equal to cot x. Find the derivative of f of x equal to cot x. F of x is equal to cot. There is only this. F of cot x. Find f dash of x. They are asking that solve. They didn't ask use first principle. They didn't ask here. Find f dash of x. If they ask, you should use that only. They didn't ask. Find f dash of x. That's all. Again f dash of x. Then we know that cot x means cos x by sin x. So I want f dash of x. To find f dash of x, which is equal to d by dx of cot x means I can write cos x by sin x. Cos x by sin x. Quotient rule I should use it. You know quotient rule. U by v. So when they are asking derivative of this, you write v square, v into u dash, u into v dash. You should remember this. Remember u by v, quotient rule. Then I can consider denominator sin x whole square, because v square, this is v, this is u. Then now sin x into, right, sin x into derivative of d by dx of cos x minus cos x into d by dx of sin x. You can consider like this. Now when I have written like this, just you apply here, you can see now, which is equal to denominator sin square x. This is sin x. Derivative of cos x minus sin x minus cos x, derivative of sin x, again cos x. Now you can observe this is minus sin square x minus sin square x minus cos square x by sin square x. We got like this, right? Here minus I can take it common, right? You can see I can take it minus common. If we take minus common here, minus of sin square x plus cos square x by sin square x. So this will become sin square plus cos square is 1 minus 1 by sin square x. This will be minus cosecant square x minus cosecant square x. That will be our answer, right? Derivative of cot x is minus cosecant square x. So just what I have done, quotient rule. Derivative of cot x from, they are asking find f dash of x. Cos x by sin x is cot x. Apply quotient rule. Then you simplify derivative of cos x minus sin x. Derivative of sin x cos x. You simplify, take minus common. Sin square x plus cos square x is equal to 1. Then you will get minus 1 by sin square x. That will be cosecant square x. That means what is your conclusion now? Finally I can conclude that d by dx of cot x will be minus cosecant square x. Correct? D by dx of cot will be minus cosecant square x. Correct? You can remember this. You can remember the list of formula. You can remember derivative of cot x minus cosecant square x. Right. We discuss one more. Find the derivative of sin 2x. The given f of x is equal to sin 2x. Find f dash of x. Sin 2x is given. So find f dash of x. Find f dash of x. They are given sin 2x. Find f dash of x. When they are asking f dash of x, sin 2x. But you can see here, the formula I can write. They are asking sin 2x derivative. F dash of x is equal to d by dx of sin 2x. D by dx of sin 2x. But we know sin 2x formula. 2 sin x cos x. D by dx sin 2x, 2 sin x cos x. 2 sin x cos x. But like 2, I can take it outside. 2 into d by dx of sin x into cos x. I can use product rule. So why can't you take 2 also? Because you can take it, I told one function like k into f of s, k into f dash of x. I can take it 2 outside. Sin x cos. Now use product rule. 2 into product rule. Sin x into d by dx of cos x. D by dx of cos x plus cos x into d by dx of sin x. You can use product rule. Then I can write 2 into derivative of, this is sin x into derivative of cos x minus sin x plus cos x into sin x is cos x. Correct. Just remember the formula. From the list of formula you should write this. This will come 2 into, this is minus sin square x plus cos square x. So I can write this is cos square x. Cos square x. I can write 2 into cos square x minus sin square x. But we know cos square x minus sin square x cos 2x. It will be 2 cos 2x. So this will be our answer. Derivative of sin 2x will be 2 cos 2x. Again a derivative of sin 2 cos 2x. Who can write that one? Derivative of cos 2x is 2 sin 2x. Right. because I have taken derivative of sin 2x, 2 cos 2x. Correct? Just sin 2x, expand sin 2x, then take 2 outside the coefficient, sin x cos x consider as product rule, then use like first function into derivative of second function plus second function derivative of first function. The derivative of cos x is minus sin x, derivative of sin x is cos x. You will get minus sin square x plus cos square x, 2 into cos square x minus sin square x. This will become cos 2x. So can I stop here? Yes, you can stop here also. If you remember, you write, but always you should remember cos square x minus sin square x is cos 2x. This is sin square. Cos square x minus sin square will be always cos 2x. Right? This is 2 now. This is 2. It will be 2 cos 2x. That you should remember. Right? Always you should remember that. Next, even sometimes they will ask using first principle, many functions they may ask, but you should familiar with to find all that using first principle. You should familiar how to solve that all the problem with first principle. Next, I can also do one more problem. Find the derivative of x plus cos x by tan x. Find the derivative of f, they will write f of x is equal to x plus tan x, x plus cos x by tan x. They will find the derivative of this x plus cos x. They are given x plus cos x by x plus cos x by tan x. They are given this, find f dash of x. You should find f dash of x plus cos x by tan x. Tan x, this is cos x. Cos x. X plus cos x by tan x. Use quotient rule. You can use quotient rule, right? They are asking f dash of x. When they are asking f dash of x is quotient rule. I can write tan x whole square. Tan x into d by dx of quotient rule. Tan x into d by dx of x plus cos x minus x plus cos x into d by dx of tan x. D by dx of tan x. Practice the same day itself. If you postpone, difficult to learn. Tan x. You can write like this now. Denominator will be tan square x. Again this will be tan square x. I can write tan x into derivative of x plus cos x. Derivative of x is 1. Cos x will be minus sin x. Right? Minus of x plus cos x into derivative of tan x secant square x. Right? It will be secant square x. I can write secant square x. So here we can express like this, because there is no simplification is not required. You can leave it. So this is the derivative of f of x means f dash of x. Because the given function is quotient, like numerator and denominator. Use quotient rule, then you can simplify like this. Here not required to simplify, we can leave it with this step. This step we can leave it now. Like this we got this one, f dash of x. Correct. We got f dash of x, we got like that. Right. Now you can see that in this problem, so I have taken quotient rule. Finally you got tan x into 1 minus sin x minus of x plus cos x by into x plus cos secant square x by tan square x. So this is the derivative of x plus cos x by tan x. Similarly we can do like many problems we can do that. In the next session I will do the different types of problems using like concept of derivatives using first principle, and also different types of problems using product rule, quotient rule. I am going to explain in the next session. I will do that next session. Now with this I will complete this session now. If you like the session, you can like it. The session is good, you can like that, or you can comment box also you can write, the chat box also you can write. Express your concerns in the chat box. Just In chat box you can do that. I'm going to end the stream now. See you in the next class again.